students, let us learn about Module 1 Differential Calculus 1. So Module 1 is consisting of these four concepts. First one being angle between radius vector and tangent. Second one is angle between two curves and orthogonal curves. The third one is pedal equation. And the fourth one is radius of curvature. So these first three, that is angle between radius vector and tangent, angle between two curves, orthogonal curves and pedal equation. All three are depending on same concept. So to find angle between radius vector and the tangent, the first one, there will be only one curve given. So these are some of the steps which I have written. We have to apply log on both the side and then apply logarithmic properties and simplify it, and we have to differentiate r with respect to theta. We are going to find the value of cot phi, where cot phi is 1 by r dr by d theta. Then we should get cot on either side, LHS and RHS, and hence evaluate the value of phi. If RHS is in terms of tan phi, then we convert into cot by using some of the basic formulas. And then finally we get the value of phi. Phi gives you angle between radius vector and tangent. And the second point is angle between two curves and the orthogonal curves. Here two curves will be given and the same procedure is followed as for the first one. So you are going to find phi 1 for the first curve and phi 2 for the second curve. So when we take the difference of mod of phi 1 minus phi 2, so that will give you angle between two curves. So if mod of phi 1 minus phi 2 is equals to 90 degrees, then we say the curves are orthogonal to each other. So if we know one simple concept, then we can find or we can solve example on all three. So pedal equation. So here also only one curve will be given. Then same procedure has to be followed. You are going to find the value of phi, and then we are going to use the follow value of phi in this equation p equals to r sine phi, and hence get the value of theta. Then from the given equation we will be substituting the value of theta or eliminate theta. And then the final equation obtained in terms of P and R is known as pedal equation. So the first concept, second and third one, in all three concepts, basically we are going to find phi. So if we know one concept correctly along with the formulas and all basic properties, we can attempt three questions in the final. So you can find angle between radius vector and tangent, then angle between two curves, and also you can find pedal equations. So become perfect in one concept which will help you to solve all three examples. Okay, and then next one is radius of curvature. Radius of curvature we have got for two types of equation. One is Cartesian form and second one is polar form. So radius of curvature for Cartesian form is given by this formula: 1 plus y1 square raised to 3 by 2 divided by y2. And radius of curvature in polar form is given by this equation: r square plus r1 square raised to 3 by 2 divided by r square plus 2r1 square minus r2. So if the given equation is in terms of x and y, which is known as Cartesian form, then we will find its first derivative, denote it as y1, and the second derivative, denote it as y2. So this value of y1 and y2 we are going to substitute in this equation, in this formula for radius of curvature in Cartesian form, and simplify it. So if particular points are mentioned, then we have to find value of y1 and y2 at that particular the point and then simplify. Similarly, if we have got